Hello, everyone. Thanks, everyone, to be here today. So I'm Renata Ravanelli. I'm a senior software engineer working for Red Hat. I actually just completed 4 years last month, so 4 years work with Red Hat. Thank you. 4 years work with this incredible team that is CoreOS. And today I'm here to talk a little bit about what actually is CoreOS and what is this operation system that is meant to be used with OpenShift and containers. For our agenda today, I will go a little bit with history, what is Red Hat and Fedora CoreOS, the difference between them, our tests and platforms, and a little bit what we have been up to, let's say, in the last year or so, about making our image customizations a little bit more flexible for users to use. And the most important thing, how to join, helping the community, and understand more about what we have been doing. Before I start, I always like to link the dots for people that are new. I know with our university, sometimes the students don't know what is OpenShift, because that's a product of Red Hat. And I really like this concept when you say that Kubernetes is like the Linux kernel for OpenShift. That's exactly that. We have Kubernetes at the core, and what comes above in the stack is OpenShift. Like any other Linux distribution, we have the kernel and above the difference between these distributions. Okay, a little bit of history. The Fedora CoreOS came from the merging of two projects, the container Linux and the atomic host. And we have the container Linux as a base about what CoreOS is today. So the main concept, the philosophy we got from the container Linux, the most important features come from there. The automatic updates, the provisioning stack using Ignition, our immutable infrastructure, and the cloud native specialization. And I think that's what for us from other distributions is kind of this concept. And from the atomic host, we got the Fedora as a base, the Linux, the kernel stack, and this Linux as enforcement. And now I will go a little bit with what is everything and describe the features for you to understand what make your Fedora CoreOS, Red Hat CoreOS, this incredible operation system. And as a concept, what is that? It always says that it's a minimal, immutable, secure, and reliable operation system that is made to run applications inside containers and managed by tools like Podman, or let's say generous Kubernetes. The difference between Fedora CoreOS and Red Hat CoreOS is basically the Red Hat CoreOS is the enterprise version of Fedora CoreOS and is meant to be used only with OpenShift. Okay, now I will describe the features that make that. The automatic updates and reliable updates, how that's work inside the system. We have the Zincari agent that monitors updates. Every time that we've got a new update available, for example, for Fedora CoreOS, we release every 2 weeks. So every 2 weeks, your system will update. And that automatic update means there is no need for intervention for the system admins, no manual action. The Zincari will realize there's a new update available, will download that. And then after that, RPMOS3 will enter in the game. What is our RPMOS3? It's the package manager for CoreOS as DNF, yeah, but RPMOS3 works as Git. Let's say when your Git, you do Git to see the tree of the change that you did. RPMOS3, it will the diff on the OS3 of the system. You can look the difference between one deployment to another. So RPMOS3, it will create a new image deployment. And in the next boot, it will make the bootloader to point to the new deployment and switch. So with that, we guarantee a full update. There is no partial update. For example, when in a normal system you do DNF update upgrade, we cross the finger that nothing will happen. your system will be open again. With the automatic updates, or you update or you don't. So if something goes very bad, what you can do, you can hold back the entire system. You hold back one image behind, the image that was previously working. So these guarantee reliable updates always. So we are secured by default doing that. And another feature that's unique to us, provisioning using Ignition. What is Ignition? Ignition is basically a JSON file where you put your configurations like including files, change user, partition file systems, and each will run only once when you are provisioning the system. Again, or each work or each doesn't work. If you, for example, you add a file, something happened, it didn't work, the boot will stop there. So in that way, you also guarantee that everything that you put inside Ignition will be provisional. And Ignition runs in the need to run FS, so that's the initial stage of the boot. Again, how we always guarantee that our updates won't break. We have extensive automating tests in our CI, and we also rely a lot on the community. Since we have bi-weekly release, we have time, since we are testing to stable, we have release every 2 weeks. So one stream will change every 2 weeks. So it gives us time to understand if something went really wrong, we can fix and have time until that reaches stable. We also release for multiple platforms. We work with x86, RHCOS, S390X, and PowerPC. Yeah. So the community web is really valuable for us in this case because we managed to get a lot of users testing and reporting issues to us. So now, what's the difference between RHEL and Fedora CoreOS? So basically, Fedora CoreOS you can use as a standalone system. And RHEL CoreOS, it's an opponent of OpenShift. You cannot install RHEL CoreOS in a normal system because it's an opponent of OpenShift. You need to have OpenShift to have RHEL CoreOS. And also, the releases are tied to that. So Fedora CoreOS every 2 weeks. And for RHEL CoreOS, it's tied to the OpenShift release. So here's our streams, as I was mentioned. Everything that's new goes to next. After 2 weeks, it goes to testing. And then after 2 weeks, it goes to stable. You also have a holdback release in case something goes very bad. You have a window for 48 hours that you can switch back if something goes really wrong. That's really nice too. As well, we have a bunch of testings in our CI. Those tests are part of our containerization tools. We have a project that is called CoreOS Assembler. CoreOS Assembler owns everything to build, test, and release our CoreOS systems. And inside CoreOS Assembly, we also support the 4 streams, 4 platforms that I mentioned. We managed to create a lot of type of image as QEMU, live ISOs, and a bunch of clouds as GPC, Amazon, and so on, and a lot of tests that are automated there. Here's just a view about our CI that I like to show. But the most important thing here, we have the cola tests that are integrated with tests, a bunch of platforms. And when you are releasing, you are also managed to launch those images in specific clouds. So not all the clouds, but as you can see, we managed to launch and test. The system is booting, SSH is working. It's just a preview of what you're releasing for AWS, Azure, GCP, and OpenStack. So we have this test before we release. Now, I will go a little bit about what we have been doing in the last year, so to make image customization a little bit more flexible and easier for anyone that wants to change CoreOS, because CoreOS is immutable as default, and that means that the operation system is being read only. And the reason you do that, because we do not encourage users to change the image, but to install new packages, everything that you want in the application level, which means create a container, install your things there, do not touch the OS, because that's not the idea. We want to have control in what is in the image, because if you had to redeploy or upgrade or something, you know exactly what is on that in each node. And if you're trying to go SSH install things, you can do install packages via RPMS3, but that's not the idea. So one case that I always like to show is the Podman case, because if you're using Podman Desktop, it's a really nice tool. Podman Desktop has the machine OS using Fedora CoreOS. So if you're using Podman Desktop, by default, you're using Fedora CoreOS. And before we had OSBuild. OSBuild is an image builder, a default image builder for OSs in Red Hat, and it has a really nice web interface that you can go there, configure OS. But for our case, let's say our intention is to go there, but it's still on development. And right now, we have the OSBuild integrated with the CoreOS assembler to help us. And why that? We also do a bunch of things that the OSBuild team was doing. So we decided to join force and delegate a part of things that was basically duplicate code. And now you're using the OSBuild to let this part with them and focus on other things, as we don't have reworking. Two teams doing almost basically the same thing. So before OSBuild, to get this Podman customization, the Podman team would need to know more about the OS, more about how to add things on the image. And when OSBuild came to the team, now everything that you need to know is how to create a container file. And that's the example of the Podman case. The Podman case has the need to have a specific packages. They need to control that because we release every 2 weeks. So they need files and specific versions of packs for their image. So everything they need to do was to create a container file using the last testing and add new configurations, build that container, send to a raster, and then CoreOS assembly comes on the history. And CoreOS assembly has OSBuild as behind, so it only gets the repository, the register key, and it will download the OC archive and build the image they needed. In their case was Apple HV and Hyper-V. That's all they need to do, provide a container file to us, and everything they will get for free. And then we also provide some automation tests, and then everything done, we'll get all the artifacts generated. Apple HV, Hyper-V will compress that, send back to a KO, where they could access and create the Podman OS machine. So here's basically a view of the pipeline. For the Podman case, they had 2 platforms, x86 or RHCOS. So we have builders in those platforms that we enable in parallel. It creates all artifacts that I needed, test that, compress, sync back the artifacts to the main builder, and then push that to their host where they can access that. And it's basically the container file doing RPM F3 replace from the exact repository they need and the package they need to change. That's the call behind, so you don't need to care. I will show a project that have everything that's done here just for you to understand how that's done. OSBuild also needs some predefined configurations on how to create the images. For example, how do I know how to create a Hyper-V, a QEMU on an Apple HV? Everything's predefined, so you don't need to care. You just need to pass the variables, and will take care of that. So that's the image builder, and we have this cool project that's called Custom CoreOS disk image. So if you wanted to try and create a new image, that's all the available artifactors that we support now. The last one that we add was the live ISO, so you can create everything from just a register. And now the golden kit that everyone is talking about, the RHEL image mode. And I want to explain here how the image mode is done inside CoreOS. The thing that I like the most is, at least for me, I always see things coming from RHEL down to other distributions. That's kind of the first time that we see the opposite. The RHEL image mode kind of start with the CoreOS thing, and then it went above to RHEL. So now I have something that's starting in other distribution, it went to RHEL. And I think that's kind of an interesting approach that we managed to do. So I won't go too deep on that. There is a plenty of talks about what is bootable container, image mode, but for those who don't know, it's just a simple example of what is bootc, bootable containers, is basically a container that is bootable. So, and how it's that done? Because they have the Linux kernel stack on that, so you can boot a container. And the image mode approach, we treat RHEL as a container. But if you're interested, look at other talks about that. Okay, and now how does image mode works in CoreOS? So in CoreOS, we have in CoreOS, we use the layering feature. Layering feature is one part of the RHEL image mode. And what we do inside CoreOS right now, we help users to customize their image via layering, and we are also building our own CoreOS using layer image. So, and here's an example in how the layer image process is done. The idea is that we'll have your cluster-based image as the base use your container file, and we'll do whatever you want with our container file using the base image from the cluster. We'll build that, push that to a raster. And when this layering feature is nice to be used, for example, for kernel changes, kernel drivers, because kernel is a thing that needs to be on the nodes, not in the application level. So these types of changes that are kind of required for us to touch the cluster and go and touch the image. And after we have built that, push to a register, we need to touch the MCO. So the MCO will get to the way, and after I build this image, I will provide my new image to the MCO. And MCO will take care of us and provide that to the cluster. Now, how you're doing that to build CoreOS? So before image mode, we had a gigant CI that covered OCP, CoreOS, and RHEL. So if something updating OpenShift, we need to rebuild everything, tested everything again. So take a bunch of time and cycles for us. And as our team, we just care about CoreOS. So if you test everything, nothing changes in RHEL, nothing changes in CoreOS. We don't need to sometimes rerun everything to get that. So we started working this year basically to split our build process as well in layer. Right now we are here. So you have an image that's only OCP. And now we have another part of the build process that's CoreOS plus RHEL. So we have first OCP image, and then when you go to there, the front will be the base image for OCP, and we will add CoreOS on top of that. And our plan is to have that, have OCP, CoreOS, and RHEL in each layer. In this way, we'll simplify our lives and decrease the time with this test and other things that's got to in your CI. Now, the most important thing, how you can contribute, you can enjoy, and you can learn more about what you're doing. One thing that I really like as an entry point for every community, doesn't need to be CoreOS, is the testing day. Because in the test day, you have the opportunity to help us testing. If without that much interactions, if you have doubts, you manage to go ask questions. We also have the how-to with every single step you need to do to test something. And what is nice about that? Because, for example, I have never used AWS, let's say. I will have to do in how exactly test something there. So it's a nice entry point for you to have a try, understand the complicated configurations. For example, we have a test testing kernel parameters, testing C Linux, testing kernel damp. If you haven't never heard about that and want to understand, test day is a really nice entry point for you. And the test day happens every major release. For example, now we will have, I think next week, the Fedora 33 test day. It is a full week when you can help testing, ask questions. We will also have a meeting on video for everyone in the community. It's an open opportunity for you to join and participate, or just look at what you're doing and ask questions. And here, for example, is one of the test case for the CoreOS key dump. We have the setup, for example, how to download the image, how to get access, the expected results. And most of this link will link back to the Fedora CoreOS main page. We'll have a page, upstream page with all the documentation, but it will basically explain how to create an ignition file, how to enable key dump. And that's the same for every single test that we have. So if you want to, that's a nice opportunity to go and learn, participate from the test week. So here's the web page for everything, the issues, forum, documents. We also have the meetings in Matrix every single week, so we have this scheduled and everything. Feel free to join, feel free to reach me, and we are looking to see all of you help us. And that's all I have for today. Still got time?
Yep. Thank you for the detailed presentation, Renata. Do we have any questions in the audience, please?
When will we see Fedora CoreOS switch to image mode by default?
We are having a bunch of discussions right now about what we want to see. I have, to be honest, not joined most of the meetings because I'm helping out other projects, but Dusty and basically Dusty is leading that right now. But there are very interesting ideas as how to use Anaconda image mode and a bunch of other nice ideas. If you want to know, I think it's every Friday maybe. I can share the link with you, but the discussions is going on, and we need to define what we want first. But any more questions? Thanks all. I appreciate the time.